water, heat capacity, vapor pressure, volume and density, cohesion, adhesion, surface tension, viscosity. Student, today I'm going to go through all these terms and explain. Let's start. Now let's talk about another formula. Density, mass-volume relationship. This is a very interesting relationship. When volume up, density down, the mass no change. Let's talk about this relationship more. Here, when volume increase, the density will getting less dense inside the particle. Let's see. Now, how about another situation when volume decrease? Now, what happened when the volume decrease? You will find that the inside particle getting more clouded and more dense. Let's see. And that's what happened. This opposite relationship reflects onto this formula. Let's talk a little bit about mass. If you see an equation x equal to y, different from a equation x equal to something over y. What's the meaning? Let's see. If x increase, y will increase. Say if 1x equal to 2y or 1x equal to 1.5y, one increase, the other will increase by 1.5 or increase by 2. But what happened to the other formula? So here, when x increase, y will decrease. When x increase, y will go the opposite way, decrease. You not believe me? Let's try. If x equal to 10, y equal to 1 over 10, smaller. When x equal to 100, y equal to 1 over 100. So now you can see when x go bigger, y will go smaller. So please bear in mind with this equation. What happened when temperature included? You will find one simple rule. Cold shrink, hot expand. This is imagine this is a common phenomena. Anything's cold shrink, anything hot expand, especially gas. Okay, let's see on this picture. When you're hot, what happened? The balloon expand. That's what happened. That's what happened on the hot air balloon. When you're hot, it expands. How about it cold? It shrink. And that's what happened. Student, please learn this density-volume relationship well. And how about the mass? The mass stay the same. They don't change. So it gives you a rule. Cold shrink, volume decrease, density increase. Hot expand, volume increase, but the density decrease. So please understand this relationship. And now we're going to turn on to the next, water. Most substance, as I mentioned earlier, anything cold will shrink. What shrink mean? Shrink mean volume decrease, it getting smaller. And shrink mean they pack more closely, it getting denser. That's what happened to most substance. However, However, water have a very special personality. When the temperature go lower and lower and low to ice, 4 degrees go to 0 degree, instead of getting smaller, it will suddenly go bigger. It will suddenly go bigger. So you can see the volume increase instead of decrease. Density decrease instead of increase. So, because the volume go bigger, ice floating on water. Because ice are less dense than water and take a bigger volume. That's why ice float. And let's look onto the molecule aspect of water. How come ice go opposite route? Let's see. In water, on this picture, water is a liquid form of water, and this is a solid form of water we call ice. What is the difference? Ice solid form are in a hexagon rigid shape, each made of a H2O, 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 form into hexagon. Water are also H2O at hydrogen bond. Same, they both hydrogen bond, no change. But what's the difference? They are moving. They are constantly moving. How about ice? Ice don't move. So, in this picture, it shows that ice have a larger volume. If you look, which ones have larger volume? Ice, when they become solid, it will occupy a bigger volume and getting lower density than moving water. This explains why ice floating in water and why ice, once water become ice, the volume suddenly expand as the density decrease. Now, let's look onto a word called cohesion, adhesion. What is cohesion? What is adhesion? Cohesion force talking about the light particle, attraction force between light particle. A attract to A is the same type of particle. Adhesion is the attraction force between the unlike particle. A with B. This is the unlike particle. So cohere, the top one cohere, the same type. Let's cooperate, work together. Adhere, different type, different type. Now let's demonstrate. You may learn from the test tube. On the test tube, the teacher told you when you do the reading on the test tube, be careful of a test tube trick, because on here the line are not very straight. They bend into a concave shape. So when the time you do the reading, do not take the top number, but you take the bottom number because of this concave shape. How come you will form into a concave shape? Now, this is something to do with the competition between cohesion force and the adhesion force. Now, let's explain. Why would it form a concave shape? Reason. Look, the water attract to water themselves. Water attract to water themselves. This is A attract to A. So this is a cohesive force. And now you see there's another type. The water attract to glass in the test tube. That is different type. A attract to B. Adhesion. This is an adhesive force. In this case, when the adhesive force is strong and the cohesive force is weak, so the water will more drag by this way. So because water love glass more than the own kind, so you drag up, so it will create this concave shape. So when you read, as the teacher will tell you, don't read from this line, you read from this line. That's why. Now let's take another example. You see, if you put in mercury, you will have a very different shape. Instead of a concave shape, you will have a convex shape. You will bend the opposite way, bend this way. Why would it be like that? Okay, now also cohesive force, mercury. This time if you put mercury, love mercury is the cohesive force. Mercury towards glass is the adhesive force. And now let's see the difference. Mercury loves their own kind more than mercury loves glass. In this case, now the mercury will drag towards its own kind, and you will bend the opposite way. And this explains. So now let's look more example. If that is a piece of, look onto the first example, glass, water. If you have a piece of glass, you drop one droplet of water. That will be the shape of the water. You will drop will look like this. Look from the horizontal. Why would it be look like this? Water attract to glass, and water also attract to water themselves. And which one stronger? Cohesion force, the water love their own kind, is weak. But water love glass more than their own kind. So you drag the water more flat on the water surface. And now, if you, in this glass, if you add onto the next one, if you add a layer of oil onto the glass surface, then you drop a water droplet. The water will standing up instead of getting flat. Why? Cohesion force and adhesion force. Now, this time, water don't like oil. Adhesion force is weak. So, and the cohesion force is stronger. Water love water. As water, why water love water? Hydrogen bond between water molecule. Remember? That's why. Now, let's look on to another word, surface tension. Surface tension. Water, why they will have an attraction force? Again, hydrogen bond between molecule. Remember, hydrogen bond between molecule. So this force, they create a very strong tension on the surface. So they will behave like a stretched skin. Let's look onto the picture. A paper clip. You will see how come I put a paper clip, they floating on the water? You're wrong. The paper clip is metal. They heavier than water. Number 2, paper clip is not floating on the water. It is sitting on the water surface without breaking the bond. So it did not break the surface tension. So you can see this clip, it does not get wet. It is sitting on the surface of the water. And then why it will be like that? Because water have a very strong attraction between neighboring molecule. That is hydrogen bond. And so if you break this hydrogen bond, you tip the clip, you will find this clip quickly sink down to the bottom. So that's proof the clip are not lighter than water. Onto the bottom picture, you see a lot of small insects like this spider. Pay attention to the leg. Look at its leg. You think it's swimming? No, they are not swimming. They are walking on the water surface. The feet did not get wet. They are not swimming. They are walking on the water surface. Because the water surface, water between water, create strong attraction force of hydrogen bond. So the spider cannot break it. So they are not floating on the water or swimming on the water, but they are walking on the water surface. The leg did not get wet. Look, the leg did not get wet. So again, what does it prove? Hydrogen bond between water. Now we talk one more, viscosity. What is viscosity? The thickness, the runniness. How easy is a molecule of the fluid can pass each other. Example, water have low viscosity. Honey, high viscosity. So water, even they have strong hydrogen bond, but these strong hydrogen bonds are quite easy to swap place to moving around. They are not in a rigid hydrogen bond. They easily swap and change. So water have low viscosity and honey have high viscosity.